गुरु ब्रह्मा गुरु विष्णु गुरुदेवो महेश्वरः गुरु साक्षात् परम ब्रह्मा तस्मै श्री गुरुवे नमः। जय श्री राम। So, hello all, welcome you all to this S.R.P मैथ्स चैनल। तो आज इस वीडियो में हम लोग रिमेनिंग जो एलिप्स के कुछ इंपॉर्टेंट प्रॉपर्टीज बाकी हैं जो हम डिफरेंट पॉइंट कंटिन्यू कर रहे थे, उसी में हम आगे वीडियो को कंटिन्यू करेंगे। और पॉइंट नंबर 3 तक हमने इसका तो थर्ड प्रॉपर्टी वी हैव ऑलरेडी डिस्कस इन द प्रीवियस वीडियो, तो यू कैन गो एंड चेक ओवर देयर if you have not watched. And also one more thing that on this channel you will find the different animation video of each and every chapters and what is there the practical lives of the maths of that chapters in your life, how they are using, all things are given in that one, huh? So go and check the playlist. तो चलिए हम वीडियो को शुरू करते हैं। आज का वीडियो हम इलिप्स में जो कंटिन्यू कर रहे हैं उसी को हम आगे बढ़ाएंगे, है ना। तो एक बार पहले हम पेन को सिलेक्ट कर लेते हैं। पेन आ जाएगा, कलर भी शायद कुछ करना पड़ेगा, जस्ट अ मिनट। सो इंक कलर आल्सो नीड टू चेंज। ओके, सो यस, एलिप्स का डिफरेंट पॉइंट है ना। तो इम्पोर्टेंट प्रॉपर्टीज वी आर डिस्कसिंग, इम्पोर्टेंट प्रॉपर्टीज। तो उसमें पॉइंट नंबर 3 तक वी हैव ऑलरेडी डिस्कस वी आर डिस्कसिंग द पॉइंट नंबर 4 नाउ, है पॉइंट नंबर 4। सो व्हाट इज द पॉइंट नंबर 4? सी point number, let us make it 4 because third already we have discussed. So this is our point number 4. So what is in this point? That the product of length of perpendicular from foci to any tangent is constant, and that constant is equal to our b square. ठीक है। So what it means, let me show you in the diagram. Suppose this is the ellipse we have here, this is the ellipse we have formed like that. यहाँ पे हमने एक ellipse बना दिया, this one. So this is the ellipse. So we can plot the tangent. Let us draw a tangent over here. Let us change the color here. Any other color will take, this one. So we will plot any tangent. Suppose we are drawing a tangent over here, like that. So this is the tangent we have drawn. This is the tangent, and this is the foci. Supposed to be, this is S and S dash, or you can say S1 and S2. We know the coordinate is here minus of AE comma 0, and here coordinate is what? AE comma 0. So if you draw the perpendicular, length of perpendicular from this foci to tangent over here, this one suppose, and from here also if you draw the perpendicular, suppose this is the perpendicular, it has length, this is P1, and suppose this length is P2, and this is the, we have plotted the tangent. So what this theory is saying, that the length of perpendicular from any these two foci to the any tangent, this will be the constant. So if you want to check, we can very easily check that what is the tangent equation. So the tangent equation, tangent T is equal to, we can write in the form of that is what, y is equal to mx plus root under of a square m square and minus, this is plus b square, right? If you take all the terms one side only, it will be something mx minus y plus of root under of a square m square plus b square, and this is equal to be 0. So if we want to find the perpendicular distance from these 2 points, so how we can write? We know the length of perpendicular from a given point. So let us write directly P1 into P2. It will comes out to be, if you put the first foci point, that is what? AE comma 0. So it will be MAE, right? MAE, and y coordinate is 0. So plus it will be root under of AM square. So it will be AM square and plus B square. Divided by नीचे में 1 plus coefficient of root under x square plus root under a square plus b square ना. तो ये तो अपने पास m है and b का वैल्यू 1 है, तो it will be 1 plus of m square का root under. So this is the value of p1. What is the value of p2? If you put, it will be simply negative, तो minus of m a e, और ये तो प्लस सेम ही हो जाएगा, रूट अंडर ऑफ a स्क्वायर m स्क्वायर प्लस b स्क्वायर, एंड नीचे भी सेम ही हो जाएगा, root under of 1 plus of m square. Clear? So if you are going to simplify this value, so what we'll get after simplifying everything, we'll get something a square m square, and if you take common, this is 1 minus e square, and this is plus b square whole divided by 1 plus m square. Okay, and this will be the mod value, right? So yes, we can take, this is a square m square and 1 minus b square. So this is the m square b square, okay or not? So this will be simply b square, you can take common, and it will be the 1 plus m square in the numerator part, and this is also 1 plus m square. So 1 plus m square cancel, and we'll get the value of b square. So yes, we got that the length of perpendicular from the foci to the any perpendicular tangent, and that will be the constant, and this constant is equal to what? B square. This is a very important property, must keep in your mind. Okay, so let us write the next property now, that is property number, I think 5, है ना? 5 ना. So what is the fifth property saying? That the harmonic mean, है ना? harmonic mean of length of focal chord is semi-latus rectum. तो व्हाट इज द लेटेस्ट रेक्टम? 2b स्क्वायर बाई ए, तो ये कितना हो जाएगा? b स्क्वायर बाई ए, तो दैट इज द थिंग्स, तो किसका वैल्यू? द हार्मोनिक मीन ऑफ द लेंथ ऑफ फोकल कॉर्ड. So let me show you in the diagram what is the meaning of that actually. So suppose this is the our coordinate system here, and this we have formed an ellipse like that. This is the ellipse we having. Okay. And suppose this is our foci, first one. So if we making any chord, suppose this is the chord we have made. Suppose this point is P, this point is S, and this point is Q, and all the other things are same, that we know S1 is equal to what actually, that is AE comma 0. So what this property saying? The harmonic mean of length of focal chord. So what is the focal chords? So focal chords are here, that is PS1 and PS2. These are the focal chord here. Right. So yes, how we can write this harmonic mean? So the harmonic mean of this is just simply put 2 into PS1 and PS1, and this side will be the Q. This is not PS2, no? This is the QS1. That is the Q of S1, not like that. One is this one, other one is this one. So yes, 2 PS1 into, here we have QS1 divided by, what is this value? PS1 plus QS1. So this is equal to nothing but B square by A. Okay, this is nothing but B square by like that. Or if you simplify, if you can simplify it a little bit, that we can write in this way also. If you take reciprocal, so it will be ps1 plus qs1 divided by नीचे में ps1 into qs1, और 2 भी था, 2 भी आ जाएगा, तो ऊपर में जाएगा तो क्या हो जाएगा a by b स्क्वायर, तो इसको हम लिख देते हैं 2a by b स्क्वायर लिख देते हैं, ठीक है। सो दैट इज व्हाट एक्चुअली b 2b स्क्वायर बाय a होता है, ध्यान रखना, तो ये 2a by b स्क्वायर हो गया। इफ यू टेक इट, इसको मैं फर्दर अगर ओपन करूं तो व्हाट इज दिस वैल्यू 1 by qs1 plus 1 by ps1, this is equal to what actually 2a by b square. So yes, we can remember this property in this way simply, that the harmonic mean of the focal radius is equal to the semi-latus rectum. That is the more easy to us. Next, point number 6 we'll discuss. Point number 6. What is saying in this point, that the intercepted portion of any tangent between the point and directrix will make 90 degree at corresponding focus। ये important है। देखिए इसका मतलब क्या है, let us suppose here we have an ellipse, like that. This is the ellipse we have formed, this is the x and this is the y. So we having somewhere the directrix, yes, so let us make the directrix supposed to be here, this is the directrix, okay. So this is the one directrix number 2 supposed to be, and this is we have taken the directrix number 1 supposed to be here, like that. What is the equation of directrix, if you remember, that is x by e, and this is nothing but x by minus x by e, okay. This is the one foci, this is the second focus s1, that is simply ae comma 0, and this is s2 simply minus of ae comma 0. So what's happening, the intercepted portion of the tangent between the points and the directrix will make a 90 degree angle, okay. So let us suppose you are drawing a tangent over here, like that. This is the tangent we have plotted. So this is the intercepted, this is the point where it's making the tangent. Suppose this point is something m, and suppose this point is something b or m, चलो m ही ले लेते हैं. So what it's saying, the intercepted portion between the tangent between the points and the directrix will make a 90 degree at the corresponding focus. अगर मैं यहाँ पे बात करूँ, है ना, तो अगर मैं इसको यहाँ से ऐसे ड्रॉ कर दूँ और इसके corresponding में ये ले लूँ, तो this angle will be here 90 degree. This angle will be what? 90 degree. Likewise, अगर मैं इसको यहाँ ना लेकर के see, let us suppose we are taking this one, मैंने यहाँ से ले लिया this one, like here, and if you draw the line from here, it will also making a 90 degree angle over here. So intercepted portion and between the any focus if you take, it will form a 90 degree angle. बात समझ में आ गया क्या बोला जा रहा है, ठीक है। तो must remember proof is that if you want, so you can simply first write the equation of this tangent. After that, if after solving with this, you can find this point, and then you can find the slope of these two, because you know this point na? Then you can say the product of slope is coming out to be -1. This way we can prove it if you want to prove. Then we'll move to the point number 7. This point saying that the angle between the focal radius of a point is bisected by corresponding normal, and the tangent will be the external angular bisector. So yes, this also we can write over here, that the angle between focal radius, focal radii, angle between the focal radii of a point, of a point, just a minute.